Hello people, I know I'm upside down. This is an alternate theory of why we see the horizon, why we see the sky as dome-like, and it's an optical illusion, I think. Initially I came up with the concept that it was the glass sky that was inverting our perception. So basically we're inside the Earth, the concave Earth, and the sky is above us, which is at 100 kilometers. And basically I thought that basically it creates this inversion, this false vault basically. However, I was looking over some Wild Heretics articles about the eye and how the illusions are generated, just how the eye works. And then I was looking into the accommodation of your actual lens inside your eye actually changes shape depending upon the distance of the object you're focusing on. And so I'm proposing this theory as an alternate to the false vault theory, where I just drew it on paper. Basically, what I'm saying is that if the sun is at the horizon, get this camera down a little bit. Okay, we're inside the Earth. You're standing here and you're looking at the sun. Light is still bending on a curve, but you're looking at the sun, and this would be at the horizon. Okay. And so the way the eye works at very far distant objects, the way the lens works, is that it's less circular, it's more flat. It's flat. It's flatter than it is when you're focusing in on a closer object. So I guess they call that, there are little, they're like ligaments here that stretch and pull the eye. They're called zonules. And then there's also the ciliary muscles that contract and expand depending, and that also shapes the shape of the eye. So basically at a farther distance, if you're looking at the sun at the horizon, the shape of the lens of your eye is going to be more flat. And so basically what's going to happen is that these light rays, the angle of incidence of these light rays are going to be coming in, and they're going to be focusing to the back of your eye, your retina. And then they're going to be coming in here, and so basically you're always focusing in on the back of your retina there. However, if the accommodation wasn't present, the closer objects, that your focus of the objects would be farther behind the retina. So basically what it does is, what the lens does, it accommodates for that. It automatically, the way the light sensors work, I guess, it accommodates. So the ciliary muscles are contracting when you're focusing in on closer objects. So if the sun is at high noon here, obviously it's much closer to you. But what I'm saying is that it's very possible that when you're viewing the sun up that close, that your lens is more spherical. The anterior part of your lens it bows out more, basically. And so what that does is it compensates, it accommodates, so it allows you to focus in again at the back of the eyeball, once again leaving it in focus like that. So, but I think what it does though is that it shrinks your perception of the image of the sun when it's at high noon. So it gives the appearance that it's actually further away from you, when it's actually the opposite. It's actually much closer to you. So that's just another theory. Let me know what you guys think about that. But I think that's very possibly what's going on there. Lens accommodation. I'll just play this video. Before that, I'll show you this animation of it first. So, okay, here's the eye, and it's looking at a distant object. And when the object gets closer, the shape of the lens has to adjust. See the back of the lens there? Once it gets closer, it bows out and it adjusts and it refocuses. And so if that's happening with the sun, when it gets close to you, when it's high over your head, I'm saying that it's possible that it actually shrinks it in the sky. It makes it look like it's further away. So therefore giving the illusion that the sky is a dome when it's actually the other way around. It's a convex ceiling as opposed to a concave ceiling.
Theory of reciprocal zonular action and formulates a new consolidated theory of accommodation as follows. The engine of accommodation is the contraction of the ciliary body mediated by the distribution of forces via all elements of the zonular apparatus. The resultant changes in refraction are due to the increased thickness of the lens and the increased curvature of the anterior and posterior capsule. The complex anatomy of the vitreous zonule results in traction on the vitreous membrane peripherally.
So basically, you have these zonules. They're like ligaments that they contract and then expand, and there's these posterior ones and then there's the anterior ones. The anterior ones, when the lens is more round like that, these are relaxed up here in front. Anterior means front. And so then you also have the ciliary muscles. So basically they are contracting when the lens is more spherical as opposed to when it's less spherical. When it's distance objects, the ciliary muscle is more relaxed, I guess. So if that's true about the sky, you know, then it gives you the illusion of the sun and the moon, the stars, creating this opposite in scale effect. So, and this would actually leave the glass sky as a non-factor in that equation. So, something to think about. But we are indeed living on the inside of the Earth. There's plenty of evidence of that. So.